Hey everyone, welcome back to the Flow Circuits walkthrough. This is part 7, where we will apply our knowledge about designing, testing, and scripting to meter out a volume of fluid. You might meter a volume of fluid to control an input to a reaction, or to split a larger volume into smaller parts. Okay, we will start by returning to the design pane and dragging in a sensor component. The sensor component detects the presence or absence of fluid underneath it. We can use this as a closed-loop feedback mechanism to control our pumps and valves in coordination with each other to accomplish many fluidic maneuvers, in this case, fluid metering. So let's consider the rest of the design. We want to introduce fluid, so we need an input chamber. And we will need to move the fluid, so we will have a pump. And wherever we have a pump, we must also have a vent. In our case, we need 2 vents because we have 2 sources, a fluid source and an air source. And since we have 2 sources, we need an option to select between them. So we'll add in 2 valves. Finally, we need an output chamber to capture our metered volume. Now let's connect everything up. Now we have a complete design, but we need to control it. All right, now we're in the test pane. Let's create a new script. The first thing we need to do is load fluid into our input chamber. Then we will need to set the valves such that we can pull from the input chamber. Now we need to set the pump to pull. Now we want to wait until the sensor sees fluid. So that's the await command, selecting the sensor and waiting for fluid. After that, we should switch valves that we're pulling from to the air source so that we slice the fluid volume between this intersection and the sensor to get a controlled volume of fluid. Then let's wait for the sensor to see air again. And after that, let's add another delay to allow the fluid slug to completely fill the chamber. At the end, we will close all the valves and turn off our pump. All right, let's see what we get. Now we can see our metered output volume in the output chamber. We can change the total volume that we capture just by moving the placement of the sensor. Great, we just learned how to implement a closed loop feedback in our script with an optical fluid sensor to meter out a volume of fluid. Now let's look at solving another common problem in fluidics design, joining 2 fluids in a channel.